Hi students, so this is our video 4, and in this video, as I have said already, that so this is the first video of our roadmap to cover comprehension. So in this video, I'll be covering these topics that I have mentioned here. So let's start with what is a sequence. A sequence is a container where elements are stored in a deterministic order or a specific order. So what does it mean by the term this deterministic order? So see, we have different data types in Python. We have numeric data type, we have sequence data type, we have a collection data type. Examples we already know. Examples are for numeric data we have int, float. Then for sequence we have a list, string. Then tuple. For collection we have set, dictionary. So sequence data type, as I said, elements are stored in a deterministic order. So this means when you populate a sequence data type, let's say a list, when you populate a list with elements, let's say we have a list of 5 elements. So when you populate an empty list, we have an empty list, then we populate the list with some elements. So when you populate the list, we insert elements in some specific order, right? And the order in which we insert the elements is same as the order in which we fetch the elements from the list. Okay, so these two orderings are same in case of sequence data types. And the minor difference between sequence data type and collection data type is, in case of collection data type, there is no specific ordering when we store the elements. Okay, so this is the difference. Then we have iterator, iterable. So they are related with each other. So actually the basic intuition is an iterator is an object. Basically both are objects, right? Iterator is an object, iterable is also an object. Iterator actually helps to fetch an element from an iterable. Okay, so the basic difference between iterator, as I said, both are objects, but the basic difference is iterator has two properties, two methods attached to it. They are underscore underscore iter and underscore underscore next. And iterable has only one property, one method, that is underscore underscore iter. Actually this method underscore underscore iter, this actually makes this an iterable. Okay, so this means we can state that every iterator is an iterable, but every iterable is not an iterator, because every iterable doesn't have that next method, right? Underscore underscore next method. So what are the purposes of these two methods? Actually, these two methods are the main point of discussion when you talk about this iterator and iterable and the differences. These two methods actually create the differences between them. Okay, so let me start with an example. So as I said, examples of iterable. So there are many examples, like string is an iterable, list is an iterable, then set is also an iterable, dictionary is an iterable. Okay, so don't confuse between sequence and iterable. Sequence, as I said, is a data type, and iterable is an object. Okay. So examples. So let's take an example. Let's say we have a list, my list equal to, let's say 1, 2, 3, 4, and 5. So as I said, this is a list. This is a iterable. Okay. And another property that every iterable has is it returns an iterator. And actually, as I said, this iterator helps to fetch an element from an iterable. So when there is a method in Python called iter, iter, we will use it. So this method actually returns an iterator from the iterable. Okay. So let's see how it works. So as I said, so let's say if we do like this. Okay, so wait, I said that every iterable has a method attached to it, and that is underscore underscore iter. So let's check that. And in Python, we have a method called has attribute. Okay, so this method takes two arguments. First argument is the object, and second argument is the property that I want to check that if that object has that property or not. So I want to check for my list, and then the property is underscore underscore iter underscore underscore. Okay, so if I run this, see, true. So that means my list has this property. So what is its purpose? Okay, so I also said that this iterable doesn't have underscore underscore next method. That is the reason every iterable is not an iterator. So let's check that also. If I say next, and here Python video 4.py, see, true false. So this means that this is an iterable and this doesn't have this property. Okay, so next thing, what is an iterator and how it works? So for example, when you do like this for LE in my list, let's say we print each element. Okay, so what it does is it actually traverses through each element of my list, and it just prints it. Okay, so our main point of discussion is how it works internally, and if when we will discuss the internal working, then we'll be able to actually make you know that what is the difference between these two terms, iterator and iterable. So as I said, there is a method in Python called iter. uh, it, it is actually attached to the iterable. So if we do like this, print iter my list. Okay, so what it does is internally it works like this. My list, sorry, my list dot underscore underscore iter underscore. Okay, so internally it works like this. So as I said, this iter, oh, I didn't explain the difference between these two methods. So what does what underscore underscore iter does is it actually returns a value. Means if we talk about this list, so underscore underscore iter returns, first it returns 1. I am talking about this loop. So it first returns 1, then it calls next method, underscore underscore next. So it jumps to the next element, then it again calls itself. Okay, so through this method, so it prints 2, then it calls again next, and so on. So this is the purpose of these two methods. One is for fetching the value, one is for jumping to the next element, as the name suggests. So as I said, this statement works like this internally. Okay, so if we print this, what we will get is, see, list iterator object at this address. This is an address, okay, hexadecimal value. So this object is stored in this value. So this will call this method, and it will return an object. So next, if we do like this, print, okay, so no, if we instead of printing, if we just save it like this, my iter, and then, so I am saving it. So this is my iterator that I am getting from this method. So iterator is nothing but a pointer. Okay, so it is a pointer that is storing that is pointing to a value. So in this case, how it works is it first points to this value, then through this method it sends back the value to the caller, then it calls next method, then it jumps to the next element, and then again the same thing goes like this. So so if we call this next, next, then my iter, and I print it. Okay, so if I print it, so, and let's say we have 5 elements here, so let's do like this, 1 2 3 4 5. So if we print this, so as I said, this is my iterator, so this is pointing to the so this is my iterator. So when we call next, this will fetch the value and it will print. Then when again I will call next, it will jump to the next value, and then again using this method it will fetch, it will send back the value here, and I am just printing it, and it will go like this. So 1 2 3 4 5, this should be printed like this. See, let me expand. 1 2 3 4 5 twice, because yeah, for this reason, if we just have this loop. Okay, so let me run again. See, so yeah, this works like this. So tell me one thing. Now we have reached the end of the list, right? We have printed 5. See, we have printed 5. So we have reached end of this list. So now if I try to do the same thing, so what should I get? So this will raise an exception, and it is called stop iteration. This means we have reached the end of the list. Let's check that. See, stop iteration. So this is the exception that I have got from this line. Okay, so now think, how can I ignore this exception, or like we just print that we'll just print that we have reached the end of this list. So we can do like this. So we can pass this inside of a try block, right? So this print, Control C, Control V, and here except. So sorry, so this will raise exception. What exception? Stop iteration, right? So this exception. So when I get this exception, what we will do? We'll just print that we have reached end of the list. We have reached end of the list. Okay, and then yeah, this is fine. So let me run. See, this time I have not got the exception. So but see this portion. in software development we have a concept of dry code, means don't repeat yourself. So we follow that principle. This is a principle. So this means this principle says that we shouldn't in our code portion we shouldn't have redundant codes. So this is a redundant code, right? We are just keep on writing this 4 times. So we can use loop. Okay, so why don't we do like this, while true, and inside this, okay, so and when we will get the exception, we'll just break and we'll just come out of the loop. See, this is our iterator, and this is an infinite loop. So it will keep on printing the next values, and when it will reach the end of the list, it will raise this exception, stop iteration, and it will print we have reached end of the list, and then we are just coming out of the loop. So let's see. See, as I said, so this means this statement, this for loop. Wait. So this for loop is nothing but internally a infinite while loop. Okay, we have seen this, right? So actually internally this for loop works like this. This next is internally called like my list dot underscore underscore next. Okay, so this is the difference between iterator and iterable. Okay, so as I said, iterator is an object and it has two properties, underscore underscore iter and underscore underscore next. So that means, so we can write our own iterator also. So let's do this. So first we'll write the blueprint, then we'll generate the object instance of the class. So my own iterator, then so this is for docstring. So if you don't know about this, so docstring is nothing but a documentation, or this talks about the purpose of this class. So what this class does is, this is a class about an iterator which performs let's say I to the power I for all I less than equal to user input. So that means user will give an input, let's say maximum value, and for all I less than equal to n we'll perform I to the power I, and we'll just return the value. So that means when you call first time, it will print if we start from let's say 1, because 0 to the power 0 is not defined. So if you start from 1, so it will first print 1, then 4, then 27, then 256, 2 square, 3 cube, 4 to the power 4, and it will go like this. Okay, and yeah, so and one thing more is we can use we can access this docstring using the object of this class, and the method is underscore underscore doc. So object dot underscore underscore doc. I will show you. Okay, so wait, so def underscore underscore the first the constructor, self, and the max, and the default value I am giving is 0. So if the user doesn't give any value, so it will consider 0. So here I am just considering max area equal to max. Okay, next def. So now we'll define those two properties, first iter, then next. So here we'll start from self, let's say self dot le equal to let's start from 1, and as I said, this returns itself, so return self. Okay, next def underscore underscore next underscore underscore self, sorry, so self here. So what it does is, it first checks if self dot le less than equal to self dot max. Okay, max area. So if it is, then it will first calculate the result equal to self dot le to the power self dot le, then it will dot le plus equal to 1, and then it will return result. Okay, and if it is not, then it will raise an exception. What is the exception? Stop iteration. Okay, so this is the case. Okay, so this is how it goes. So let's see. So it will first this is the constructor portion. So let's say if user gives 5 as the max value, so it will first when we create the instance, say my iter object equal to my own iterator, and I'm passing value as 5. Okay, so this calls this method, and it will assign max element as 5. Then I'm just calling then my iter equal to iter, and as a parameter my iter object, so this one, so it will return, it will call this method, it will assign self dot l equal to 1, and it will return itself. So what is itself? The iterator, and it will assign here. So when we call next time, so print next my iter, and if we do this 1 2 3 4 5, okay, so first it will it starts from 1, so first it will print 1, because 1 is less than equal to 5, so then 1 to the power 1 is 1, then 2 square is 4, 3 cube is 27, 4 to the power 4 is 256, 5 to the power 5 I don't know, then yeah, so it will go like this. So this is the reason I said that internally it works like, so my iter dot underscore underscore next, see, and in this case my iter dot underscore underscore iter. So let's see what is the output. See, first 1, then 2 square, then 3 cube, then 4 to the 4, and this is 5 to the 5. So we have our own iterator. So now the last thing, so if we print again, so now self dot l equal to 5, okay, so 5 self dot l equal to 6, it has printed 5, it has printed this one, so it will increment by 1, and it is now 6. So 6 is not less than equal to 5, so it will raise a stop iteration. So let's see that. See, stop iteration. Okay, so to avoid that, we can do like previously as we did. I will show you again. So while true, this is my iterator. So try print this one, control C, and this one control V, and if it has an exception, except stop iteration, except stop iteration, then what it will do, it will just print that we have reached the limit, okay, and it will come out of the loop. Okay, so let's see. See, first it will, first for 1 it printed 1 to the power 1, then 2, then 3, then 4, then 5, and then it will raise exception. We are catching that exception here, and we are printing that we have reached the limit, and then it is coming out of the loop. So this is how it goes, and this is how we can create our own iterator. So yeah, that's all for today.